In example 5, we're going to look at a scuba diver who is going underwater. The deeper he goes, the more water pressure he feels. Refer to the table to see the relationship between the depth and water pressure. So when we analyze this table, we notice that the meters are increasing by 5 each time. So 0 to 5, 5 to 10, 10 to 15, 15 to 20 adds 5 each time. If we look at the water pressure, 0 to 50, 50 to 100, 100 to 150 to 200, we're adding 50 each time. For part A, we're asked to describe the relationship between the diver's depth and water pressure in words. Well, in words, we would say, for every 5 meters, the diver goes underwater. The pressure increases by 50 kilopascals. Then we're asked to look at that in a graph. So we're going to plot the points. So remember, in a graph, we should have several things completed. So we need a title. So we're going to call it something simple: Scuba Diver Pressure. And just a reminder that on our horizontal axis, that's our independent variable. So that would be our depth. And our depth in this case is measured in meters. So we start at 0 where the two axes meet. Our table increased by 5 each time, so I can use that scale. On the vertical axis, I'm trying to write upside down, that's pressure, and it's measured in kilopascals. And that graph increased by increments of 50, or that table rather. So I can use that one, that scale in mind. So my independent axis is increasing by 5 each time, and every block represents a 5-meter increase. Kilopascals, I can increase by 50 each time, and every block represents an increase of 50. That's important. So the diver started at the surface of the water, so that's 0. At 5 meters, the pressure was 50 kilopascals, and we can plot our points. 20 and 200. And then we look at the graph and we say all of the points lie in the same straight line. So the data is linear. But now I need to decide, do I need to connect them? Connecting them has nothing to do with whether or not they make a straight line. It has to do with, does it make sense to have parts of values? So if this diver is going 5 meters below the surface, is it possible for him to go 4, 3.5, 0.5, 0.26935? And yes, all of those values can be measured as the diver descends to the ocean floor. So because those parts of values, 0.5s make sense in this scenario, then the data is continuous and we can connect those points using a line. Our last question then is write an equation. So if we look at our table, for every 5-meter descent, the water pressure increases by 50. If I look at my table, to go from 5 to 50, to go from 10 to 100, to go from 15 to 150, I'm multiplying by 10 each time. And that 10 is going to help me with my equation. So I'm multiplying by 10 each time through here. So my equation, if I'm going to use P for pressure, the pressure the diver experiences is increased by 10 for every single meter of depth that he goes through. So let's just test our equation again. So for a depth of 5 meters, depth is 5, 10 multiplied by 5, that's 50, correct. The depth is 10 meters, 10 multiplied by that 10 is 100. There's my equation that describes the scuba diver's situation.